Yeah. Chapter 2, Rolling Stock. The first railway cars were merely horse-drawn wagons they introduced in 1602 to transport the loads English mines in navigable streams where the coal was transferred to vessels. The wagons equipped with the handbrakes reduced the speed where they started rolling faster with the gait of the horse from the gait of the horses. They pulled them with wooden wheels and rolled them on wooden wagons. Way over the rails called tramways. Experience can be provided with the wooden wheels. Railways wore out or quickly had to be replaced. Frequently, they lead to metal wheels and rails, but a team iron past individual groove limited capabilities. Horse wagons could not meet the demands of transporting ever increasing tonnage. Some method of transportation was needed that could carry heavier loads and withstand long use. With the steam locomotive was built to replace the horse of the wooden wagon roadways, iron rails. Later, steel ones were developed. Railway cars were designed to build to replace horse-drawn wagons. The original railway cars were constructed to handle minimum loads of locomotives and roadbeds to truck structures. The other years road structures have been improved and equipment made longer, more efficient, larger, heavier, stronger, and safer. And the railroad's private car owners included the Army now own operating vast heavy-duty railway fleet. Today's piggyback flexi-wagon cars provide a high degree of capability of maximum empty cars movements of return trips. Containerization expanding continually and is being used increasing with the containers of a flat car becomes all-purpose cars. Advantage of the fast loading, unloading, freight handle labor is reduced and damage to the landing is decreased. The chapter describes some way the railway equipment Army ones that emphasize place on the foreign services knockdown fleet can be used in the theater operations anywhere in the world. The chapter also discusses other freight cars, passenger special equipment, and recently developed rail car which may prove very desirable in the transportation of nuclear weapons. 2 rolling stock. Types of rolling stock. Railway rolling stock is classified into 4 types: house cars, open top cars, flat cars, and tanker cars. All-way railway cars, except for flat cars, have 6 general components: trucks, brake gear, draft gear, couplers, underframe superstructure. The flat car has no superstructure. The only 5 general components of the following subparagraph discusses each of the 4 types of the cars in the order mentioned. The house car is an enclosed superstructure with the sides, ends, roof, usually doors, vents, ladders, roof running up the boards. Boxcar, refrigerator, and cabooses examples. Since boxcars, refrigerator cars are discussed in paragraph 213 and 219, the only caboose is described as a caboose is the car attached for the rate of to the rear of the freight train. Accommodates the conductor. Flagman serves as their offices and quarters while they transit. The caboose will always also carry supplies, tools, carports that might be required en route. The open top, such as the gondola, ballast cars, and the hoppers, normally have said ends. However, both of the type of the hopper cars covered on the open top are included in an open top category. Following the subparagraphs describing 2 types of the hopper in the ballast car, the gondola is discussed in paragraph 212. Covered hoppers are permanently enclosed with weather-tight cars, fixed sides, ends, and roofs opening with the weather-tight covers, doors provided with the roof sides, and from which the car is unloaded. For unloaded, the car must have openings bottom of the tighting fits. The covers, doors, ports, or valves, or roof side openings with the freight might be discharged. Covered hoppers may be partitioned into the compartment. 2 open-top hoppers are similar to gondolas except that they have higher sides, ends, and generally interior with self-clearing features. Examples: sloping construction of the car, bottom of the compartments at the end, the openings equipped with doors providing discharge for the car's contents. Open-top hopper cars and are many of the type of the vary according to the size and commodities of the carry. Some of the have twin hopper pockets, while the others are quadruple ones. Each has door on this discharging laden. Ballast cars are similar to slow sliding gondolas, except for the low may be discharged from the side. Some referred to as the side dumping gondola. These cars are used for the hauling ballast, sand, gravel, small loads of coal. Flat cars are no housing or body. They simply fly on the floor laid of the uniform frame sills. The load capacity of flat cars range from 50 to 250 tons. Examples are basic flat cars, depressed center ones they describe further in paragraph 211 and 218. D. The tanker cars, which tanks mounted on the special underframes. They may be counted liquids or semi-liquids commodities ranging from milk to TNT. The Interstate Commission issues a regulation specification governing the tank car used in the United States. These specifications are combined with the American Association of Railroads to make a specification covering the car construction, with the ICC publishing for the overseas use. Specifications are modified because of the emergency austerity demands. 2.3. The freight equipment of the military use. For instance, the railway car being used for the military purpose probably occurred with the Civil War, when the motors permanently mounted on the flat cars as moved into the area to support troops. In 1917, the 5 naval railway batteries were built and shipped to France for use of World War I campaigns. Each battery consisted of a gun car carrying 14 12-inch guns and ammunition, workshop, kitchens, berthing cars, and the 14 cars of each battery were probably the first railway cars used entirely for military purpose. Army Railway motive power rolling stock built using domestic services, different little in design standard U.S. commercial rail equipment. In comparison to foreign equipment, however, the generally is larger and heavier. The World War II began in Europe. Rolling stock had a smaller carrying capacity and was scarce in all theater operations. Many cars were hurried, designed, and built in the United States and shipped overseas, knocked down to save shipping space. A few American cars were modified for use of the European railroads. For example, experience led to the development of the railway fleet capable of operating the railroads in various gauges, which could be sent quickly to the areas conflicting. Some of the equipment can be shipped knocked down to conserve shipping space, or Sections 1 describing the knockdown equipment. Section 1 Knockdown Fleet. 2.4 The General. For experience of World War I and II showed that the foreign railway system incapable of suiting combat operations because of the capacity amount of the foreign railway equipment were not enough military purpose for the U.S. Army. Realized it had been too prepared to produce its own motive power rolling stock should it engage the enemy on foreign soil. Soon after World War II, the Army began to develop a feedable, suitable for use of theater operation. Objective railway cars were modified in American car design capability, operating foreign country into the train with the locomotive equipment, starting with a basic flat car that could be converted to gondola boxcar. In addition, with the proper superstructure, these cars were designed to work with the coupling, braking systems, equipment, and the principal railroads of the foreign countries to be capable of operating railroads various gauges. Keep in mind, with the requirements, American designers developed a basic flat car. In addition, with the domestic service equipment, the Army inventory contains a knockdown fleet of 40-ton equipment designed and built primarily for emergency overseas service. Another one for the use of narrow gauge track on the foreign theaters were proposed not to procured, but it was consisting of a 76-ton diesel electric locomotive, 30-ton gondolas, 30-ton flat cars, 55-ton depressed center cars, and 40-ton fleet cars consisting of more than 11,000 items of motive power rolling stock and storage. Various Army depots installation. Paragraph 2.5 through 2.10 discusses generally the construction components of the cars, foreign services fleet, and basic procedures assembling knockdown cars, and the reminder of the section accompanying with the figures described in the car's fleet and that can be assembled and partially assembled in the theater, and explain their assembly and the conversion. 2.5 The construction. Because of the accepted short life of the emergency equipment using the theater operation as compared with the standard equipment, the fleet constructed a simple, economical, military standard permanent design of the equipment funneled in the physical characteristics of foreign railroads will limit the capacity of the dimension. For example, track and bridge load limits would determine the equipment at axle load, while the clearance would affect its dimensions. The designers decided that the capacity of 40 tons was best to transport to military supplies and equipment on the standard to the broad gauge of 51.5, 60, 63, and 66. Designing modifications were based on equipment shorter life expectancies. Regulation expected to govern the rail operation in theater. Emergency overseas equipment is designed to meet the clearance and limitations of foreign railroads. The major assembly components of the different types of knockdown and interchangeable cars. Paragraph 2.6 and 2.9 discuss the four basic components of a railway car of the knockdown fleet, with the exemption of tanker cars. Paragraph 2.10 discusses their assembly. 2.6 The multiple gauge track enables the knockdown fleet to operate the railroad various widths with those standard or to regard gauge. The trucks can be adapted for the different gauge from the entire truck may be not removed and another substituted. Checking the gauge of the wheel once set on the multiple gauge track can be accomplished only by general support maintenance units. While the wheel cannot be pushed in or out or at will, the heavy-duty wheel presses is required. The multiple gauge track can be applied to locomotives, record locomotive cranes, snow plows, and other railway equipment. Trucks and wheels used in the equipment of the fleet and conform the standards of the U.S. Army Association of American Railroads, completely interchangeable among the cars in some same capacity. Only the major assembly, however, the interchangeable among the trucks themselves. The diagram of the typical railway truck is shown in Figure 2.1. 2.7. The couplers. Because the fleet is designed primarily for service in overseas, it is equipped with a hook and link coupler predominantly in Europe, Russia, and other parts of Asia. The inserted sketch shows the hook and link of the couplers as well as the bumpers absorbing the jolts. Figure 2.2 is the model of the car equipped with a hook. Linker coupler and bumpers equipped for the flat feet, designed so that it can be used in a standard automatic U.S. coupler. Here's a picture of a pair of trucks starting from 12 o'clock in clockwise. Side bearing, the axle, the center plate, the brake lever, the brake hanger, the brake shoe, the wheel, the rail, the brake pin, the bottom connection rod, the journal box, the side frame, the spring plank, the coil springs, and the bolster. 2.8. The underframes. Equipment of the fleet uses steel underframes fabricated and drilled in car builder shops in the United States. All underframes from flat cars and gondola box cars are assembled in the same way. Wooden plank floors is laid over the underframe. 2.9. The superstructure. Made generally of wood and metal reinforcement bars. Superstructures units provide only rigidity. They are not designed to support an applicable amount of weight of the landing. Superstructure units are prefabricated, punched, and drilled and reassembled for rapid assembly. Here's an 210. The general method of assembling a car from the knockdown and exemption of the tank cars flows first from the assembled trucks and the underframe. This installs miscellaneous items of underframe, including air braking equipment applying for the underframe ended seals such as the coupling draft gears, buffers, blockers. Next, mounted the underframe assembled for the trucks. Lastly, attached to the body set, bearing shims wear to the plate, the bolster, rail recorded and the proper superstructure. The components assembled of the cars are packaged with quantities that permit the issue of the cars in multiple tens. Components common to all cars are packaged separately from those peculiar ones in one type of car. 211. The flat car. Known as the workhorse rail service, the flat car is used to transport very large, very heavy items. The basic unit of the knockdown flat car is simply the floor laid over the underframe placed on the trucks, and there's no housing of the body. Shows the major components of the flat car. Figure 2.3. Components of the assembling flat car. 2.4 shows the car after assembly. Flat cars in the knockdown fleet are structurally designed with load capacity of 40 tons, adding the serving regular flat cars. 40-ton cars are also provided foundation superstructure units can be converted into them gondolas and box cars. 2.4. The assembled flat cars. Underframes of the flat cars of the 40-ton fleet are shipped with a wooden floor already laid. Flat cars underframes are completely interchangeable with any of the other car of the fleet. The side end of the sills are flat car prefabricated, punched, and drilled. This is the underframe in a flat belly car. In the theater, the flat car generally is used to vary every rail operation. When the theater activity stabilizes, the requirements to increase the transportation and supply needed protection, whether a pilferage, the flat car can be converted to a closed car. After conversion, weight of the lighting is still carried by the car bed. The structure provides rigidity, not support, because of its versatility. The flat car is the backbone of the fleet. 212. In addition, with assigning the basic flat car becomes a gondola, either the high side of the 48 inches, low side 18 inches. Gondolas may be assembled depending on the height desired. The only difference in the two cars is the height of the superstructure. Shows a flat car being converted into a high-sided gondola. Shows that after assembly, high sides of the engine gondolas in the knockdown fleet made a 1 1/2 inch tongue groove wood sheeting of the metal and reinforcement bars may be used on the 40-ton flat car underframes. Manner adjustment the corner bands and ends. This is a gondola car with the end of the conversion of flat car gondola generally position sides, underframe sides, and sills, securing them with a place of fastening, handholds, positions, ends, assemblies, securing corner posts on all corners of the car's gondola can transport a variety of the heavy bulk items. They are used primarily for carrying such materials as coal, ore, stone, lumber, iron, steel products, and machinery. If necessary, they can be used to transport troops. 213 boxcars, enclosed with the side ends having a roof, and the boxcar is designed to carry commodities that must be protected by breakage, pilferage, weather damage like the gondola. The boxcar, the knockdown fleet can be assembled by adding a proper superstructure to the flat car underframe. Made to the light frame of the plywood lining, the superstructure consists of a main line, side end doors, and a roof. The sides are constructed into 4 separate sections, 2 of each side. The ends are single units. The roof is 1 unit. The door assembly consists of a door track, threshold plate, and door. The shows the flat car underframe boxcar superstructure under assembled. Figure 2.8 shows the assembled boxcar with the door open. To assemble the car, underframe is assembled the same as the flat car with the exemption of the chamber, adjusting the corner connection angle, single step, and the handholds of the two-sided section adjacent to one end of the car are first attached to the underframe. The end of the unit connecting the two hoses, the two-side section attached to them, and the end sill of the underframe. Same procedure followed in the other end of the car. When the side sections and the end units are erected, the door tracks and the doors are in their proper place. The roof is positioned and secured to the corners and sides. 214. The tanker car. A tanker car consists of a tank usually made of steel mounted on the rail on the car. A special underframe, except for the superstructure, is modified underframe. The tanker car has a component similar to the other cars. The underframe is a floored and steel running boards are built on each side of the heavy even with the flooring, made with a corrosion-resistant material. The tank shields may be having either a single compartment or multiple ones. The ordinary tanker car has a single compartment equipped with dome-safe valves and bottom outlets. To prevent corrosion, the linings are required in steel tank are to be acid. To seal tanks, when acid are shipped in them, some may be insulted to provide even the temperature required certain commodities. In addition, some cars may have steam coils installed inside the tank shell to provide heat for the lading. The tanker cars are used for the transportation of liquid, semi-liquid commodities such as oils, gasoline, and alcohols, acids, coal or tar, produce compressed gases, fruit juices, and milk. Tank capacities use the range of from 5,000 to 10,000 gallons. A typical U.S. Army tanker car is shown in Figure 219 figure. This is a U.S. Army tanker car. Tanker cars in the Foreign Service fleet have single compartments, would normally carry petroleum products. The 5,000 gallon operates on a narrow gauge railway, while the 10,000 gallons one runs on a standard to broad gauge track. The car manufacturer assembles the tank unit to the car underframes along with the outlet and save the valve with the assembly dome cover. The remaining work can be done in the field. It all consists of assembly, applying for the following sub-center sill and center plate to tank the underframe, assembly of the tank and the underframe assembled to the trucks, miscellaneous parts issued to the brake equipment, supports the underframe parts to the end of the sill, air brake to the underframe, body siding to the bearing, shims and wear to the plate of the body bolster, such as miscellaneous items as a tank ladder and braces for the tanker car to the body and tank. 215. The experience of in World War II provided that the Army must be prepared to supply its own locomotives, railway cars, and theater operations. Since many foreign countries have just enough rail equipment to support their own needs, military tonnage requirements placed on their rail system would not only exceed the capabilities of the equipment and facilities, but also create a near chaos in their operations. Therefore, to meet the emergency, U.S. Army inventory contains a fleet of railway equipment specially designed and built for use in theaters of operations where standard to broad gauge are operated. In developing the Foreign Service equipment, designers found that the physical characteristics of foreign railroads would influence the size and capacity. They decided that the capacity of the 30-ton was best for equipment that would operate on a narrow gauge railroad, and 40 tons for equipment operating on a standard to broad gauge. However, only the 40-ton fleet was procured. The car was fabricated, punched, and drilled at the car builder's shop to provide for easily assembling in the theater. They can be shipped knockdown fleet To conserve shipping space, major compartments assembly for interchangeable with the minimum modifications to the coupling and arrangement and the substituting. The trucks and altering trucks to fit different gauges in the 40-ton equipment can operate out on the standard broad gauge track ranging from 56.5 to 66 inches. The flat car is the basic unit of the knockdown fleet. It can serve as a regular flat car during early theater operations. When the theater activity stabilizes, other types of cars are needed. The flat car can be converted into a field to be a gondola or box car. The gondola can be assembled and adding sides to the end of the flat car depending on the height desired. Either the high or low-sided gondola may be erected. When the cars are needed to carry the commodity requiring protecting the weather of the pilferages, and the flat car converted to a box car by the addition of sides and ends and doors and roof. After the flat car has been converted to either the gondola or a box car, the weight of the landing is still carried by the bed of the superstructure. Units provide rigidity but do not support any applicable amount of weight. Tank cars of fleets are partially assembled by the car manufacturer who attaches the tank unit to the car underframe along with the outlet, safety valve, assemblies, dome cover. The remaining assembly can be done in the field. Section 2, Other Equipment. 6. Other Equipment. 216 general. In addition to the knockdown fleets described in paragraph 211 through 214, some heavier weight freight cars, some passenger cars, some equipment must be built in special purposes, including the foreign service fleet. This section discusses the rolling stock in addition with some of today's newer development in rail equipment. 217, the 80-ton flat cars. Since some of the 80-ton flat cars are included in the overseas fleet carrying the ordnance engineering equipment weighing no more than 140 tons. Example is seen in figure 210, similar to the 40-ton flat cars. On large, these cars are designed to meet some of the railway operating restriction in theater. They are shipped and knocked down or are packed for easy assembly. However, the converting of them to gondola or boxcar is not planned for at present because of their greater load capacity. Each of the cars is mounted on two 6-4-wheel trucks. The 3-axle part per truck to avoid exceeding the low axle load on a foreign railway track, bridges, and other rail structures which are designed to support a certain amount of weight per axle. Within 6-wheel truck were distributed evenly over the greater area than a 4-wheel truck. The more weight of that can be supported, the 80-ton flat car designated to operate on a standing broad railroad gauge is an 80-ton flat car, 6-wheel truck. 218, the depressed center flat car. Flat cars were low and depressed center, having designed and built and not for transportation, ordnance, engineering, material, equipment would be exceeding permissible heights of loaded, unregulated flat cars. This useful is measured mainly on the added headroom and their afforded the clearance of the 70-ton depressed center flat car designed for foreign services has two 6-wheel trucks, as shown in figure 211, operates on from the standard broad gauge 56.5 inch to 66 inches. The 219 refrigerator car. The refrigeration is the more moving perishable items. Controlling the temperature is essential to protecting such food as fresh fruits, vegetables, and from freezing in the transit. Refrigerator cars can be used in both purposes: to keep commodities cool and to protect them from too much cold. A car can be cooled with ice or by mechanical means. Standard refrigerator cars reassemble the box and generally outward appearance. The framework, sheeting, and the ending of the roof are similar to those at the end of the standard boxcar. Constructing except the insulation has been added or on an ice-cooled refrigerator car. The roof has been openings from which the ice is loaded. In figure 212 shows a refrigerator car with its hatches visible. Refrigerator cars are developed in foreign service fleet and are 40-ton, 88-wheel ice-cooled cars. They have the same type of underframe trucks and brake coupler and arrangements as the other cars in the foreign services fleet. And the superstructure outside of the sheeting is plywood. 2 ice bunkers are installed, one at each end of the car to receive the ice from the hatchet openings in the hinge metal racks and placed over the floor. The side ends of the roof and the floor are insulated with fiberglass. Here's a refrigerator car. 220. The passenger equipment car. The ambulance train cars are only the passenger equipment included in the Foreign Service fleet because of the experience of the Army Medical Service during Korea and Vietnam Wars, the rapid development of the air transportation, and the quick evacuation of the wounded from the combat. The requirement for the rail hospital car in the theater is not as great as years ago. However, the ambulance train provides a temporary facility to care for the sick, wounded patients while transporting them to center points where they can be evacuated to air base by air-to-base hospitals. After World War II, the Surgeon General requested that ambulance cars consist of three types of cars: a ward, a medical and personnel, kitchen, dining, storage, and be designed, developed for use of foreign railroads with standard to broad gauges. The cars would have the common underframe superstructure design, interior arrangements, fixtures appropriate to each type. The three-car prototype train was designed and constructed and has been placed in storage. The cars of ambulance are constructed in steel and have interchangeable underframe superstructure components. They are built to resist greater impact forces and provide maximum safety and comfort. They have multiple gauge four-wheel passenger type of trucks. Coupler arrangement is designed to permit the rapid conversion to another coupling arrangement of the standard to broad gauge trains. Each car is insulated, ventilated, and equipped which only heating the power generating plants and water supply system only. The wand air card is additional. The car windows is designed to complete the blackout. The three cars of the train are designed to operate as such units as furnish complete railway ambulances facilities. Each type of the car is discussed in the following subparagraphs. A ward car located in the midway of both sides of the center aisle. The ward car is a tier bunks to accommodate 30 liter patients, 12 liter and 24 ambulant patients. 6 bunks is stationary. 24 can be converted to seats. Other facilities necessary to the patient's comfort and care are included in the sterilizing equipment, a laboratory, an air conditioning system. A receiving room is located at the platform, sliding side doors, and provided for the receiving of patients into the car. B. Medical personnel. Personnel of Army and Medical Services are provided with sleeping quarters, dressing rooms, toilet facilities, in the medical personnel car. It is equipped with the two air circulating blower units that contain staterooms for 4 officers, 2 nurses, and 15 enlisted men. Kitchen, dining, storage room spaces for storing medical food supplies, preparing, servicing, and fooding is contained with the kitchen, diner, storage. The car is divided into 3 sections, with the kitchen, such cooking facilities, the stoves, refrigerators, steam tables, bindings, the complete meals and dining areas, the tables to seat 24, and cleaning area containing a service sink of storage space for medical food, cleaning, and supplies. This car also has an emergency water supply. 221, the special equipment to reduce the time required for various types of operation to speed up the repairs, labor-saving machinery, tools, or provided. Special equipment designed for special purposes has been built for the use of railway operations. 2 types of such equipment included the Foreign Service fleet are cranes and snow plows. Cranes and loading and unloading cars are moving supplies and material. Cranes help to speed up many of the railway operations, clearing railway lines when traffic has been interrupted by washouts, landslide, wrecks, and other causes. In one of the many tasks for which the crane can be used, the crane in the Foreign Service fleet can be especially useful in handling heavy truck assembly, bulk superstructure units, and erecting cars out from knockdown fleet. Figuring 213 shows a crane in use. Here's another one. The snow handling equipment. Clearing the snow or the ice on the railway is important to keeping the railroads operational. See here whether the snow handling equipment is in Foreign Services. The fleet year-round. Multiple purpose of the track maintenance is an additional clearing ice and snow from the tracks during the winter. And in this snow plow is also called the spread ditcher car. The spread ditcher car can be used during other seasons for the year to do a variety of jobs. Some of these include spreading and leveling ballast, ditching from former slopes, and banking, moving dirts and fill material, widening road beds, and cutting and building up reinforced road beds, removing foul ballast from the end of each tie. A sketch of the spreader ditcher is inserted below. 222 Special railway cars. Some of the Army's highly refined weapon systems, such as missiles, rockets, and nuclear warheads, pose special transportation problems because of their size and sensitivity. While in the transit, those weapons may be damaged, and handling and environmental convenience of itself. Therefore, special care must be taken in moving and protecting them. One of the more recently developed railway cars is designed with both the piggyback and container services, equipped with a shock-absorbing mechanism that provides a higher degree of protection for the equipment. Lading, shown in Figure 2.14, is the 13 basic elements: a container, a trailer chassis, and the piggyback rail car itself. The following sub-paragraph discusses this equipment. It's a piggyback car. Container specifically designed to build and operate interchangeable between road and rail and ship and containers. That key is containerization transportation. It could be used to lift off, roll on, or roll off services. The container is built in lifting eyes, casting on all four corners, and is engineered with withstand stress on lift or on lift operations, as are at ports, rail terminals, and loading dockings. The corner posts of the construction permits stacking and fully loaded containers. These features design constructions are particularly desirable in ship operating where a crane is in one particular means of loading and unloading containers. Some containers have a fork pocket that enable them to be loaded unloaded by forklift trucks. Pulling the container on or off the railway car is done with a power-operated winch that provides the power to draw the container on and off the car. The container is locked onto the railway car, but the same kind of tie-down clamps are used to secure the ordinary truck trailers. The trailer chassis, designed to build and accommodate the container. The trailer chassis has a device to unlock and unlock container easily and quickly. The chassis is moved by the truck. The tractor operates depending on either the rough country roads or smooth city streets. The chassis is equipped with the piggyback adapter equipment so that it can be driven on and off the piggyback railway car. From front to rear, it's engineered and built for container services. C. The piggyback railway car, designed exclusively for container piggyback services. The piggyback railway car is equipped with a shock absorber with the absorb 75% of the shock for the car receives. Then a certain guide automatically aligns the container to the trailer so that the loading and unloading is smooth and continuous hands-off operation. Automatic tie-down hitches are operated in the truck tractor with the back down onto the railway car secures the trailer containing the shock absorbing mechanism. Because the load is carried lower than on the ordinary rails, this piggyback car provides a railroad clearance. For the largest trailer, where normally in use, provision is also made for the purpose of future changing in width with the trailers because they are on no side rails to interfere. Mixed loads of the containers, conventional trailers can be on the piggyback of the railway car without modification. It can transport containers, chassis with or without the containers, tank of the tank, containers, tank trailers, semi-trailers, furniture, vans, automobile carriers. Car is the full capability with ordinary flat cars, both mainline yard service at a present military traffic management command (MTMC) leases a limited quality of the equipment when they need for the use of domestic interchange. The equipment is now a part of the Army's foreign service fleet. 223. The Foreign Summary. The Foreign Services Fleet contains a special freight car such as the 80-ton depressed center flat car for varying large, very heavy ordnance engineering equipment, including the fleet of the ice-cold fiberglass insulated refrigerator cars to carry the perishable items, the cranes, snow handling equipment into the speed of the various jobs and keep railroads operational. The only passenger car included in the fleet of the Foreign Service ambulance train, which consists of three types of car: a ward, medical person, and a kitchen, dining, storage car. A prototype for each of these three cars has been designed, built in storage and broad gauge rails. They are now in storage. The ward car contains a facility of the patient car comfort, including an air conditioner system, sleeping quarters, dressing room, and toilets. Facilities are included in medical personnel cars, the kitchen ending of the storage cars containing the kitchen with facilities and prepare complete meals, the dining area where the meals to be served. A cleaning storage area contains a service sink, a small space for storing and supplying. Special equipment for the Foreign Service fleet of the cranes, snowplows, cranes helping handling heavy equipment. The snow handling equipment cleans the ice and snow from the tracks. In addition to using during the winter months, this machine is also called the spread ditcher. It can be used during either during other seasons of the year for various track maintenance jobs. Finally, the MTMC leases a limited quantity of the railway car designed both in container and piggyback services for use in the United States because it has greater shock absorbing capability. The equipment may be very effective transportation, highly sensitive weaponry. This equipment, however, is not present as part of the foreign service fleet. Chapter 3 Maintenance of Equipment.